Today we're going to cover section 9.3, test about a population mean. The name of that test is a one-sample t-test. What are the three conditions? It's the same three conditions we're used to, random, 10%, and normal. For normal, the sample comes from a normal population, or n is greater than or equal to 30 because of the central limit theorem. If we don't know these things, make a graph and check for skewness or outliers. Please remember that if you make a graph to check for skewness or outliers and you think you notice skewness or outliers, then state that you are going to proceed with caution. Don't just stop and not do the test. State, I'm going to proceed with caution, okay? But still check the conditions anyways. All right, what is the test statistic for this test? It's a t statistic, and it's t equals x bar minus mu over s sub x divided by the square root of n, okay? All right, the calculator steps. You're going to go to a calculator page, hit menu, choose statistics, choose stat test, and then t-test. And then on t-test, it's going to ask you for data or statistics because your problem's either going to give you raw data or the problem's going to give you the statistics from the data, okay? And so you have to choose based upon which one the problem gives you. If you have raw data, before you can run the test, you need to put the raw data into a lists and spreadsheets page. Okay. All right, the 4-step process, same as the proportions except for the do step, we're going to add degrees of freedom. All right, let's do an example. It says, every road has one at some point, construction zones that have much lower speed limits. To see if drivers obey these lower speed limits, a police officer used a radar gun to measure the speed in miles per hour of a random sample of 10 drivers in a 25 mile per hour construction zone. Here are the results. Can we conclude that the average speed of drivers in this construction zone is greater than the posted 25 mile per hour speed limit? So the first thing we're going to do, because they're giving us raw data, is we're going to go to our calculator, going to add a page to a document, add a list and spreadsheets page. At the very top of column A, the very top of column A, why don't you just name it speed? Because that's what we're talking about, miles per hour speed. Okay? Then go down to cell 1 and type in all the raw data that they give you. Okay? Once you've done that, then press play and we'll go back through it and you can use the calculator to find your answer. Okay? All right, but we're going to go ahead and set up the test. Let mu equal the true mean speed of drivers in the zone. We're talking about mean speed, so we're not talking about p proportion, we're talking about mean. So we're talking about mu. We will test the following hypotheses at the alpha equals 0.05 significance level. H sub O, remember the null hypothesis is a statement of no difference. So we're going to say mu equals 25. In H sub A, they believe that people are driving faster than 25. So mu is greater than 25. We will perform a one-sample t-test for a population mean if conditions are met. Random, stated, random sample. 10%. We assume 10 times 10 equals 100 is less than or equal to the total number of drivers in the zone. That's a reasonable estimation, a reasonable assumption. Normal. We don't know that the population was normal. They didn't tell us that. We're only doing 10, so that's definitely not greater than or equal to 30. So we must draw a dot plot. There's a dot plot. I don't see any strong skewness or outliers, so I'm going to proceed. Okay? So now I'm going to go to my calculator, and I'm going to get a calculator page up, and I'm going to go menu, statistics, stat test, t-test, and then for the data input method, I'm going to put data, because that's what I have. I have raw data. It's going to ask for mu 0, and that would be 25. Then it's going to ask you for your list. So hit the right arrow for the drop-down menu and choose speed, because that's what we titled our list. The frequency list will stay 1, and the alternative hypothesis is greater than. Once we put all that in there, it gives us everything we need except for the degrees of freedom. We have to figure that out ourselves. Degrees of freedom is 9 because it's n minus 1. Then we get our t from the calculator is 2.05, and the p value is 0.0069. So we have everything we need. Okay, so let's write our conclusion. Since the p value of 0.0069 is less than alpha equals 0.05, we what? We reject H sub O. There is convincing evidence of what? Convincing evidence of the alternative. That the true mean speed of drivers in this zone is greater than 25 miles per hour. Okay? All right, next example. It says, in the children's game, Don't Break the Ice, small plastic cubes are squeezed into a square frame. Each child takes turn tapping out a cube of ice with a plastic hammer, hoping the remaining cubes don't collapse. For the game to work correctly, the cubes must be big enough so that they hold each other in place in the plastic frame, but not so big that they are too difficult to tap out. The machine that produces the plastic cubes is designed to make cubes that are 29.5 millimeters wide, but the actual width varies a little. To ensure that the machine is working well, a supervisor inspects a random sample of 50 cubes every hour and measures their width. The Fathom output summarizes the data from a sample taken during 1 hour. So this time we have the data. We have the statistics from the data. We don't have the raw data. We don't have all 50 data points, but we have the statistics from the data. Okay, so we don't have to go and make a list or a spreadsheet. All right? So it says, do these data provide convincing evidence that the mean width of cubes produced this hour is not 29.5 millimeters? Use the significance test with alpha equals 0.05 to find out. So here we go. Let mu equal the true mean width of plastic ice cubes. We will test the following hypotheses at the alpha equals 0.05 significance level. H sub O is mu equals 29.5. My H sub A is mu is not equal to 29.5 because that's what the question asked. The question said not 29.5. Not greater than, not less than, just not equal to it. All right? We will perform a one sample t-test for mu if the conditions are met. Random, it's stated random sample. 10%. We assume 10 times 50 is 500, is less than or equal to the total number of cubes produced by this machine each hour. Normal, we know that 50 is greater than or equal to 30, so we're good to go for the normal. All right, so go to your calculator, go menu, statistics, stat test, t-test. This time choose stats, not data, and go ahead and input the information that they give you over here on the side. On the side, they give you the mean, they give you the n, they give you the standard deviation. You don't need the bottom number, you don't need the standard error. Just use the top three numbers, mean, number of your sample size, and your standard deviation. Degrees of freedom equal 50 minus 1, which is 49. The calculator gave you a t of negative 0.4595. And your p-value is 0.6479. That's a pretty large p-value. So here we go. Since the p-value of 0.6479 is greater than alpha equals 0.05, we failed to reject H sub O. There is not convincing evidence that the mean width of cubes produced this hour is not 29.5 millimeters. Okay? Next part to the question. It says calculate a 95% confidence interval for mu. Does your interval support your decision from part B? All right, to calculate the confidence interval, you don't have to go back and check all the conditions. You don't have to go back and rename your parameter. Just calculate the interval, okay? Just like we did in chapter 7. So when you calculate the interval, you get 29.47 and 29.52. Does this provide convincing evidence that the mean width of the cubes produced this hour is not 29.5? No. Since the interval includes 29.5 as a plausible value for mu, we do not have convincing evidence that the true mean width is different from 29.5. This is the same conclusion as part B. Okay? I failed to reject, meaning I don't have evidence of the alternative. And then here, because 29.5 is within my interval, then I don't have evidence that it's not 29.5. Okay? Last example. For their second semester project in AP Statistics, Libby and Catherine decided to investigate which lane was faster in the supermarket, the express lane or the regular lane. To collect their data, they randomly selected 15 times during a week, went to the same store, and bought the same item. However, one of them used the express lane and the other used the regular lane. To decide which lane each of them would use, they flipped a coin. If it was heads, Libby used the express lane and Catherine used the regular lane. If it was tails, Libby used the regular lane and Catherine used the express lane. They entered their randomly assigned lanes at the same time and each recorded the time in seconds it took them to complete the transaction. Carry out a test to see if there is convincing evidence that the express lane is faster. All right, if the express lane is faster, then we want regular minus express to be greater than 0. We want regular to be larger. Express to be faster, that has to be a smaller number, so when I subtract, I want a positive answer, greater than 0. Okay? So what I'm going to do over here on the side, is I'm going to subtract regular minus express and write that number over here on the side. So I'm going to do that for each one of these. Each one of these pairs, I'm going to do regular minus express, and I'm going to write it over here on the side. Write the difference on the side. Some of them were positive, some of them were negative. Nonetheless, write the difference on the side. Okay? All right. Then I'm going to create a list and spreadsheet page. Title it difference. On the list and spreadsheets, go to the top of column A and title it difference. And then starting in cell 1, type these numbers in. Because we have raw data, so we have to put it in the list and spreadsheets page. Okay, now we're going to perform a significance test. These are considered one sample because it's a matched pair. Okay, this is a matched pair experiment, so it's considered one sample. We'll look at 2 samples in the next chapter. Okay, so here we go. Let mu sub d, we're calling it mu sub d because it's the difference between the two. It's not just mu. Let mu sub d equal the true mean difference, regular minus express, in time required to purchase an item. We will test the following hypotheses at the alpha equals 0.05 significance level. Notice they didn't give me the significance level in the problem, but when they don't give you one, you use 0.05. Okay? H sub O, mu sub d equals 0. I'm saying that there is no difference. Remember, the null hypothesis is a hypothesis of no difference. Alright, H sub A, mu sub d is greater than 0. I want regular minus express to be larger than 0. We will perform a paired t-test for mu if conditions are met. We're calling it a paired t-test, but when we do it in the calculator, we're just going to use the regular t-test. Okay? Alright, first condition random, stated random. It tells us that it's random. 10%, it's not sampling. We're not taking a sample of something out of a big population, so there's no need to check the 10% condition. Normal condition. We have less than 30. We don't know that the population is normal, so we're going to make a dot plot. There does not appear to be any strong skewness or outliers. But again, if I thought there was strong skewness or outliers, I would say, I think there's strong skewness or outliers, therefore I will proceed with caution. But go ahead and finish the test out. Okay? Alright, so here we go. Degrees of freedom, 15 minus 1 is 14. When I go do the test in the calculator, I got t equals 1.97. P-value is 0.0347. Since the p-value is less than alpha, we reject H sub O. There is convincing evidence that the express line is faster than the regular line.